Hey, Stephen. So here I have some sample data for my uh, Markov chain using doing a career progression um, through an organization. What this is measuring is to see using a continuous time Markov chain to see how many people are in the state of training, turnover, promotion, etc., at any given time, and this would enable the company to be able to forecast. I don't know how I turned this thing on. My cat did it actually. How I would be able to forecast. Oh God, hold on. I'm going to pause this. In order to forecast how many of their employees would be in any state at any given time, and then be able to either increase recruitment, increase training initiatives, both for promotion and or lateral stages in the organization, as well as preparing for whatever processes need to be handled during for voluntary and involuntary turnover. So to start, I already have these packages installed. So I'm just going to load them. Here it shows that they are loaded. So next I have an example of stages of career progression, and the purpose of this sequence, this is the object sequence, and these are the stages that an employee may go in through their career at an organization. And so that would be employment, training, then an incumbent for 2 years, back to training, then they get a promotion, they stay in that promotion role, so they're still an incumbent, and then they leave the company for turnover. So the purpose of this is to check to see if, so now I have this object of the sequence, and now I want to see if this sequence has a verified Markov property. So I'm going to use the verify Markov property function, and I'm using the object sequence. I'm going to run it, and all it has done right now is enter it. So next you can see that it tested the Markov property on the data sequence, and it says that the chi-square statistic is 3.66, 3 degrees of freedom, and the corresponding p-value is 0.29. So as long as the p-value is not significant, then this does mean that the sequence follows the Markov property. So I'm good to go. So next I'm going to start creating the objects that I need for my Markov chain. The first thing that I'm going to do is create the disk states. This is the function that holds this is an object that holds all of these states within my Markov chain. And I'm just going to be creating these objects that will be kept over here in the environment. Now I'm saying that this Markov chain is going to be handled by the row, and that I'm going to enter the data by row and not by column. That is what this function is true for by rows. Now I'm going to create the matrix data, and I'm going to call my matrix career matrix by using this function. The data is what I'm entering here. These data represent the probabilities of the employees being in which state of the career progression, what percentage of, or the probabilities an employee would be at each stage during each given state time. Now, I generated this data. Actually, I didn't generate this data. I borrowed this data from a article. It was Forbes and Carroll, and it does not have to do with career progression at all. So I just borrowed this data because I didn't know how else I was going to get some except for making it up. And so then I have by row equals still by row, but it's different because this one is capitalized. And then the number of rows is 6. Then the names, this div names is for the names of my columns and of my rows. For my dim names or the dimensional names, I'm using the same names for the columns and the rows. So these could be different if I wanted to, but this matrix is the same by column and by row. So I'm just going to go ahead and run all of this so that I can get my Markov chain in. So it's just run it. Now I have the data in the career matrix, and it looks like this. So the names are the same in columns and row, and so it's fitted nicely into this little table. So now I have my data. So now I'm going to create my Markov chain using or creating the Markov chain object MC Career using the Markov chain career matrix. And this is a new Markov chain using the states, these disk states up here, by row using the transition matrix, career matrix here. And I'm going to name this the Markov sim. Oops. So, and then I'm just going to print it. And all this does actually is create a table of the same data that I have here. The next thing that I'm going to do is look at what the initial state would be. Now this would be the initial state, the first round of data, and this would count the number of employees that I have in each state that I have identified above. These disk states is my initial state. I'm going to create that object. It is here. Then I can begin to forecast a little bit by using some vector mathematics, allowing R to do that math for me. So after year 1, I'm going to calculate the number of people in the initial state and multiply it by the career matrix. I'm going to print that first year, and this is how many people that I have forecasting in each state. So I have not done a gap analysis in this, but I can see that I've gone from 150 people in initial employment to 75. So I would recommend that the organization needs to, and that's like about half, I would recommend that the organization needs to begin some training, and then I've had a little bit of turnover. So the next thing that I'm going to do is look at after 2 years, but instead of multiplying just the initial state times the initial state, I'm going to take the totals from after year 1 and multiply it by the original state matrix. Now, this forecasting would be more accurate, or I don't want to say accurate, this forecast would be more useful. I'm going to go ahead and run the print after 2 years so I can see my new totals, because I'm not calculating in the new people that I propose to be employing. But if it was possible to get a new matrix every year, then a new state matrix every year, then Markov analysis would not be useful. But it would become more useful if these values were an average of the probabilities over a number of years. Then these outputs would be closer to forecasting or more likely to forecast future states. So now I've printed after 2 years. I need to know if there are any absorbing states and transient states within my Markov chain. Absorbing states are states that once you go into, you cannot come out of, and transient states are states that you can continue to move through. So the absorbing state is turnover. What this means is that once you turn over in the company, you're not coming back. Once you quit or retire, then that is the end of your career. And so all the other states here are transient states. So now I want to do a little forecasting and just thinking, and this is more like internal planning. So I'm going to create an object called career of years, and I'm going to have R, using my Markov chain, MC career, forecast 50 states to employment, and what a progression of 15 transitions from states would be. So it's just going to run that, and it's going to create this career of years. And then I'm just going to print 20 of those to see what they look like. And so promotion, 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 and then staying in incumbent. This specific or this example of a career progression, this person has stayed on for, has never left the company, you see. So that could be interesting, and just knowing how often and how often a employee gets promoted through the organization, and how long they may stay in one certain place. So of course, the data that I use has nothing to do with career progression, so this may come out funny, but for the purposes of looking at what this code is going to do when I get actual data, I think that it's really interesting. Now, the next important step is this even a fitted model? So I created this model, and this Markov chain has a function for that. So the type, I'm using the maximum likelihood estimate in order to fit the model. This is the recommended function or estimator for this type of Markov chain. So the data that I'm using, and this is to test the fit, model fit. So the data that I'm using is still my career of years. The method I'm using is MLE, and I'm just calling this career MLE. And I can create this object or create the data. So I created the data, and it's a list of 6. I wonder what this looks like. So here we go. I have the estimate, the standard error, the confidence level, the lower endpoint matrix, the upper endpoint matrix, and the log likelihood. And then the next thing that I do is actually I'm just printing these out. So I don't think that I actually need to, I'm going to go ahead and do it. But that's what all of these are. So this one object, this career fitted MLE, created all of these, and I can use these functions to print them out, but they're just right here. So this is the lower and the upper endpoints of the confidence interval. And this value right here is fitted log likelihood of the MLE. Awesome, I'm really excited to do this in real life. Thanks, Stephen.